Hi there. Are you ready for today's science adventure? Here's a fun question. Can sound really break glass? Let's find out. First, what is sound? Sound is vibration. It starts when something moves back and forth like a tuning fork. These vibrations push the air around them, and the air carries the sound in waves all the way to our ears. Next, let's understand sound waves. Sound waves are patterns of air pressure moving outward from something that is vibrating. Some parts of the air get squeezed, this is high pressure, and some spread out, this is low pressure. Waves can be high or low in pitch. This depends on how frequently the vibrations are happening. They can also be loud or soft. That depends on how strong the vibrations are. Now, let's delve deeper into understanding what frequency and amplitude mean. First up, frequency. Frequency means how many vibrations happen in 1 second. We measure it in something called hertz, and we write it in the short form as Hz. More vibrations per second mean higher frequency, which means higher pitch, like a whistle. Fewer vibrations means lower frequency, which in turn means lower pitch, like a drum. So frequency tells us how many times the wave vibrates every second. Next, amplitude. Amplitude tells us how strong the vibration is. That's what makes a sound loud or soft. Bigger vibrations mean more energy, means louder sound, like a gong. Smaller vibrations mean less energy and softer sound, like a ticking clock. So amplitude tells us the strength of the wave. So, can sound make things vibrate? Well, when sound moves through the air, it bumps into things. Even hard objects like glass can start vibrating if the sound is strong enough. But objects vibrate the most at a very special tune. This is called their natural frequency. It's like every object has its own favorite vibration rhythm. Let's understand that better with resonance. Resonance happens when the sound's frequency matches an object's natural frequency. It's like pushing someone on a swing. If you push at the right moment, they swing higher and higher. That's what resonance does. Each sound push makes the object vibrate more and more. If the sound gets too strong, the object might even break. Now, back to our first question. Can sound really shatter glass? Well, yes, but it's rare. The sound has to be the perfect pitch and loud enough. But yes, opera singers and scientists have actually done it. Well, resonance isn't just about breaking stuff. We use it in many different and smart ways. Musical instruments like guitars use resonance to make sound louder. Buildings are made with special parts to reduce shaking during earthquakes. And medical machines like ultrasounds use sound waves to make pictures of inside the body. Now let's go over the main points that we learned today. Sound is vibration that travels through air in waves. Sound waves are patterns of air pressure. Frequency means how often the wave happens. It affects the pitch. Amplitude means how strong the vibration is. It affects loudness. Objects vibrate best at their natural frequency. Resonance happens when sound matches that natural frequency. Strong enough resonance can even break glass. But we also use resonance in music, buildings, and medicine. Okay, time for a quick quiz. Let's see how much you remember. First question. What does frequency measure in a sound wave? Is it how tall the wave is? How many vibrations happen per second? How fast sound moves through air? Got your answer? The correct answer is how many vibrations happen per second. That's frequency. How often the wave repeats every second. Second question. A sound with high amplitude will sound, will it be softer, slower, louder? Think about how strong the vibration is. Yes, the answer is louder. High amplitude means stronger vibration, and that means a louder sound. Next question. What is resonance? A type of echo when sound matches an object's natural frequency? A sound made by machines. Remember the swing example? The right answer is when sound matches an object's natural frequency. That's what we call resonance. Next question. Why doesn't sound break glass easily? Could it be it needs the perfect pitch and loudness? Glass never vibrates. Only machines can break glass. Think back to what makes resonance powerful enough. Correct. It needs the perfect pitch and loudness. That's why breaking glass with sound is rare. Everything has to be just right. Last question. Which of these uses resonance in real life? Electric fans, solar panels, ultrasound machines. You guessed it, ultrasound machines. They use sound waves to look inside the human body. Great job, curious minds. You followed the waves, cracked the mystery, and uncovered the real science behind the shatter. Keep asking questions. The world is full of cool science waiting to be explored.